Welcome back to our series on ASA cluster on firepower appliances. In this video, we're going to take a look at the resiliency of our data links and cluster control links with ASA cluster. When ASA cluster is running on firepower 4100 appliances, it uses Firepower Chassis Manager, FXOS, to add interfaces into port channels for its data plane and control plane that you see here with port channel 10 and 48. This is an ASA 1 and this is an ASA 2 unit. They all have their ports green. And as we install either ASA or FTD app, we can also cluster those applications together using the chassis manager itself. You can see here that I'm running an ASA application, and this particular unit is ASA 2, a slave in our ASA cluster, and we also have ASA 1 chassis manager that has the same ASA application installed but is acting as master unit within that cluster. So let's take a look at our resiliency of the data links. What we're going to look at is taking out the data links 1.1 and 1.3 that I showed you here are part of the port channel 10 on our ASA 1 appliance here. So you can see that these two links are part of the port channel 10, and we will shut them down on both switch 1 and switch 2, causing that unit to pull itself out of the cluster. And after that, we're going to follow up and work on the cluster control plane. So once we actually recover that unit back in by re-enabling and adding it back in, the connections that were owned by this ASA 1 unit are now going to move to ASA 2. So we'll focus on removing the ASA 2 unit by bringing down its cluster control link and see how that again is reflected on our test connections. So let's take a look at the data link resiliency first. Here we have our test connections up and running. 2 SSH connections, UDP, and all the ICMP is running. Now let's take a look at our console for ASA 1, show cluster info. It still owns all of those connections. If we take a look at the show connection output here, we see that ASA unit 2 is backing up unit 1, and this is connection in context 2. Now let's take a look at context 1. We see also the backups in place for context 1. So now looking at our switch, show port channel summary here. We have our ASA data channel here. So for unit 1, we're going to shut down Ether channel 1.1 on switch 1. Taking a look at our connectivity, it is unaffected. And looking back at our ASA unit 1 here, we're looking to see this data port 1.1 to show as red, and chassis manager is going to catch up here pretty quickly. In the meantime, I'll just take another look at the port channels on switch 1. And I do see 1.1 port as down. And now I see that port is also showing down on the chassis manager. We'll proceed and do the same on switch 2. Show port channel summary there, shows Ether channel, Ethernet port 1.1 as up. Interface E11, we shut it down real quick here, and this will cause our cluster detected by ASDM. There was a change in a cluster. Since we were logged into the master and it has transitioned, it's going to shut down our ASDM. On the console, we see that this unit had disabled. Looking at our TCP connections, they're still functional. And looking at UDP connection, we had a loss, we had a pause in traffic for about a second here, but those packets were paused and received in the next time interval there. All of the ICMPs are still working. So if we take a look at our chassis manager here, it will catch up to actually state that Ethernet 1.3 is also down. So there it is. Both of these ports are down now on ASA 1. Now let's bring that unit back in by first enabling those data ports on both switches and manually bringing this unit back into the cluster. If I take a look at the cluster config, it will try to rejoin in 2 minutes, but in the interest of time, I'm just going to do it manually from the console here by typing enable under cluster group configuration. So here I can see that the configuration is syncing between the two units. And showing connections in context 1 on ASA 2 shows that 2 connections are now owned on ASA unit 2. So we had now transitioned in ASA 1 unit into a slave, and we can see that they're properly put in their states. We don't see any effect on traffic. The UDP, TCP connections are still up. So now what we can do is proceed to actually work on resiliency of the cluster control link. So in this case, we have our unit 2 of ASA with 2 ports, Ethernet 1.4 on each switch, being used for the cluster control link. So let's take a look also at our second unit here. It has all of the ports in green. Chassis manager for unit 1 has also caught up to show both ports in green, so we'll be looking at bringing down the control plane for unit 2. So first let's work on switch 2. We'll shut down that port, take a look at our connectivity. It is unaffected. We still have one more link on ASA 2 used for cluster control plane, so 2 units can talk to each other with no issues. Everything is in place. Taking a look at our chassis manager, it's going to catch up to show Ethernet 1.4 to be part, to go down as part of that cluster control plane. We will take a look at bringing down the switch 1. Yep, there it is. It has gone down. Now let's bring down the other port as well. So as I do this, I see that ASA 2 had disabled. ASA unit 1 had picked up as master, and looking at all of our connections here, we had seen about a 1 second pause in UDP traffic. The TCP connections are still up and running, and all the ICMP connections are still going. We'll do the same and review the chassis manager. The second port is also going to show as down as chassis manager catches up. We will simply proceed to bring the control plane back in action. So one thing to notice here is once this unit had lost its control plane, it took itself out of the cluster, and it also brought down the data plane, because we cannot have the switch sending and black holing the traffic into the data channel and ports of this unit when it's outside of the cluster. So all four are going to show as red. And if we look at the logical devices for this particular unit, it will show that the cluster role is none, meaning that it's outside of the cluster. So let's bring it back in and see what effects it has. Do a no shut on switch 1, do a no shut on switch 2, and now we will do the same and manually bring it back into the cluster. This will force an election process to happen. They will determine that there is a master already in place, and it will start syncing that configuration. In the meantime, you can see that Chassis Manager is catching up with bringing those ports up, and here we'll bring our cluster back in and see if it has any effect on our UDP traffic here. I can see that the cluster unit is now transitioned to a slave, and we had built our ASA cluster back up and have the two units handling traffic appropriately. FXOS for unit 2 has caught up to show all units green, and this device is also now as part of the cluster and should show cluster role as slave, and that there it is. So in this video we showed you resiliency of the ports in an ASA cluster. When we actually brought down ASA unit 1 that owned our test connections, then we recovered it, look at what effect it has on test connections, and then we worked on bringing down the second unit by taking out its control plane and recovering it as well. So that concludes this video on port redundancy. Thank you for watching.